Hello everyone. Welcome again to Global Azure 2022. This session is part of the Global Azure stream for this year, and I'm very glad that we will talk about Azure IoT Edge and AI. I would like in advance to add some information about local event which will be held next week this year. Exceptionally, in Bulgaria, we have local event 1 week later because of long holidays here in Bulgaria. So I would like to say big thank you to our partners and hope that you will have very good moments not only on the global Azure stream these days, but also next week at Global Azure Bulgaria. We will talk about intelligent edge solutions with Azure IoT and AI. We will start this session uh, doing more conceptual vision about such kind of solutions, and probably next week we will have in our hybrid event, again it will be streamed, but we will have also presence in person. We will have more deeper session related to the same context. So, my name is Michiel Matev. I'm PhD on computer science, and I'm also community enthusiast, one of the leaders of Bulgarian Microsoft community, focused mostly on Microsoft Azure and Data Platform, IoT, and related AI solutions. We will talk in this session about IoT Edge. IoT Edge is not only for IoT, it is a framework which is foundation for many other edge functionalities for Microsoft Azure services. We will talk about architecture overview. We will go deeper into some details. We will talk also about best practices with Azure IoT Edge, and we will have some practical demos. If you have any questions later after this presentation, feel free to contact me. You can find me in social networks, you can send me an email, and you can visit also my blog. What exactly is IoT Edge? Because for IoT Edge, we have different um, concepts in general, and for specific frameworks, we will talk a little bit more about exact IoT Edge in general, and we will talk a little in details about Azure implementations. As you know, IoT is one of the main trends in technology industry, and we have nowadays between 50 and 60 billion connected devices, and connected devices stay more and more, and this technology trend stay more important for the global industry. That's the reason to talk also about specifics, and especially for IoT Edge. I will make just short overview because IoT has application in almost all possible business domains, all possible industries. We discussed this in many other sessions, so I will not go into details, but we will see use cases related to edge solutions in this presentation. When we talk about IoT Edge, things are not so new. Actually, edge computing is not a new concept because from the past it was very important to have computing resources exactly where you collect data. And after that, things stay client server, stay more cloud oriented, and later, computing came back also in balanced way between edge and backend, usually hosted into the cloud. So many years ago, everything started with CDN concept. As probably many of you know, CDN or content delivery network is a very important technology used to distribute content into different endpoints. And CDN is very popular nowadays. It is not possible to load fast static content without CDN. Uh, After that, you started to see peer-to-peer solutions where different users, different local infrastructures started to communicate in between. After that, we move to cloud computing. Cloud computing is the main trend in our modern industry, but cloud computing also expect to have some transportation between edge and backend. So regarding to this, cloud computing need to solve several important cases related to small response, shortest response when you need to have immediate results, and transportation expenses and latency in general. Uh, After that, we stay to use different solutions where you can have several different layers of distributed computers, like, for example, fog computing. And today, it is very important to have computing resources on the edge. Why on the edge? Because of several important specifics. First, a huge amount of data is needed only for specific purpose, and it will be great if we can use it on site, but we have no need to transport this data to the cloud and to collect it for a long time. So if we have computing resources on the edge, it is much simpler, cheaper, and easier to manage our data and to have optimal cost for our solutions. The Azure concept, the edge concept is actually very important for all modern solutions. Usually, when we talk about edge computing, we have uh, computing resources which are connected to several different layers where we have nodes. Nodes means where we have on-site some functionalities to have some activities and collect data. We need to have, for many reasons, computing resources, storage, to be possible to make some analysis in the same place where we get our data. And on the cloud, we have again computing because for overall analysis, we need to have different computing resources, and it is something which is also important. Many years ago, it was only edge computing. After that, we moved to cloud computing, and now, as I explained, we have distributed solutions. If we take a look on high-level architecture of IoT solutions, we have different sensors. We can have more complex structure on site, including sensors, um, embedded devices, different computing resources, and also infrastructure devices like routers, firewalls. Each group of devices is connected to the backend using gateway devices. We name these devices from the edge side IoT gateway. These devices quite often have also edge computing functionalities. There are also cases when these functionalities are only related to data transportation. We will talk about details a little bit later. On the back office, we have very different services and our analytics resources are practically unlimited if we are using cloud solutions. The only one limitation is up to the reasonable price to use such kind of solutions. Edge analytics um, usually simplify the solution. Imagine that you have, for example, some sensors and you need to send some information to your back services related to specific cases. Quite often, it's much more effectively if you can make first step of analysis on site to be possible, for example, to filter information and only if you have some um, anomalies to send information to the cloud. Depending on your uses, edge computing can be very important in different level and to actually save a lot of cost. But case by case, the advantage of edge computing, of course, can be measured in different way. Edge analysis allows to simplify to make more universal also your backend solution. You can have pretty general sample. For example, if you have home automation, you can have for your home automation devices which are connected to some local board which is mounted in your infrastructure, and we have a lot of main functionalities in this infrastructure. Instead, each device to send information to the cloud. Of course, you have in real world both cases. You can buy a lot of smart devices like cameras, sensors, which are directly connected to the cloud because you have solutions where vendors offers IoT as a service, and these devices are directly connected to some backend services, and you can using web interface or mobile app to have an overview of our connected devices. Again, it is up to specific cases. Usually IoT edge solutions require all devices to be configured in the proper way and to support such kind of functionalities or to have custom solutions. But if you consider operational cost, it could be in many cases much more effective and much more cheaper. There are several key benefits. First is privacy. Why privacy? Because you have many specifics related to two different aspects: security and also compliance and regulations. Regarding to security, it is much more important if you don't want to allow some sensitive data to go outside of your local infrastructure to keep analysis and access to this data on the edge. But quite often we have also cases related to regulations, compliance, privacy, where we have some restrictions to share this data outside of specific um, local infrastructure. This data should be in specific location, in specific region. It is very important for private data. It is important also for healthcare, again, related to personal data. It is also important when we talk about confidential information related to the business. So in this case, we can simplify and make better our solutions if edge computing is implemented in your solutions. The second, which is also very important, is related to the latency. Immediate response from some services is very important. Imagine that you have production line, and on this production line, you need to have fraud detection. For example, uh, you need to have immediate reaction when something happen on your production line. In similar situations, it is also very important to have edge computing resources. From another hand, if you have emergency solutions, for example, if you have some vehicle and some parts of the vehicle, like for example brakes, engine, need to be controlled with some intelligent systems, quite often sending information to the cloud and receiving back response um, uh, require some latency, which is more than expected for safe and proper reaction in your solution. So in these cases, also edge computing is very important. And the third aspect is reliability. Why reliability? Imagine that we have solutions. Again, we can make samples with some vehicles, vessels, some solutions which are organized remotely, or you have moving devices and vehicles. You still can have situations where temporary internet connection can be not very good. In this case, you cannot rely to backend services, and reliability is very important to support the proper work of the whole solution. So, general cases regarding to IoT Edge are pretty clear. Benefits are also easy for understanding. And when we have IoT Edge, we need to specify also some additional specifics. When we talk about IoT Edge, we talk mostly about several things. We need to run some workloads at the edge. That means we need to have some flows related to data analysis and transformation on the edge. In this way, we reduce bandwidth, connection specifics stay simpler to solve. We have not so high requirement for connection and bandwidth related to this connection. We can have much more optimal solution on the next steps in our end-to-end workloads. That means some data which is needed only on the edge can be used on the edge, and this data can stay on the edge and later to be deleted. Only data which we need for long-term analysis and analysis from other places will be transported to the cloud. In this way, we have more clear design. We have simpler solution on the other parts of the our system. And for specific edge analysis, quite often we just need to have important functionalities on the edge. I mean, if you have, for example, uh, recognition of some forms, moving recognition or something like this, usually it is not efficient to do everything on the cloud, and this solution to wait analysis to be provided on the cloud and to go back and actually your system to wait for some response. There are additional benefits which we already discussed. Uh, Reliability, reducing of the cost stay higher. We have much better security when we are using edge deployments, and also edge devices quite often act like gateways, which is a very good advantage. When we talk about core edge features, usually we have from one side uh, complex event processing. That means your edge devices can collect data from different sensors, some uh, kind of analysis related to this complex events processing can be done on the edge, and after that, information to be sent to the backend where other services has no idea about this specific between different sources. Offline support and data management are also very uh, important and simplified in the context of edge solutions. And some important use cases. Near to real time response for your solution when you have local changes. When we need to deploy and manage containers on your edge devices, container containerized applications are very important, and this concept actually changed the whole edge way of IoT edge way of thinking. Security in any aspect, offline support, specific AI analytics, optimization of the data cost, and privacy. Let's now talk a little bit more about Azure IoT and Azure IoT Edge, because in Azure we have also some specifics. When we have IoT solutions related to Microsoft Azure, probably in Azure you have more than any other cloud platform related especially for IoT components. And it is pretty easy to start building IoT solutions using these components and following the reference architecture. The reference architecture provided from Microsoft means that you have good guidances how to start. Even in some cases, these solutions will be not very optimized. You need to make additional tuning after that. Following these guidances, you will not make mistakes, and your solutions will be good enough at least to have first steps and first stages of implementation for your solutions. In a Microsoft IoT stack, you have many services which are um, especially designed for IoT, plus services which can be used for different goals. Specific services are services like IoT Hub, device provisioning service, for example, but we have services which can be used in several different ways, like, for example, stream analytics. Stream analytics can be used on the cloud for IoT solutions and on the edge, but it can be used also for different purposes. When we need to think about edge solutions in Microsoft Azure IoT stack, we have a little more specific implementation, and we will talk about this. And this implementation is also related to the main trends: low power connectivity, analysis on the edge, increased security. uh, Devices which need to be used for edge computing actually consume a lot of computing resources related to just sensor-based devices. This is the reason, one of the main trends to be to optimize this consumption. This can be done in different way, and we will talk also about this later. There are also different solutions related to IoT Edge. Microsoft probably offers the most complete end-to-end solution, but also you can see different solutions from AWS, from Dell, from Intel, IBM, Oracle, PTC. So definitely, edge analytics platforms are very competitive. And regarding to business domain, usually first insights are related to autonomous vehicles, remote monitoring of different assets, smart grids, predictive maintenance in hospital, patient monitoring, um, radio networks and 5G, cloud gaming. There are very interesting cases, traffic management, smart homes, retail advertisement, video conferences, and many other. When we talk about Azure IoT Edge, we have these things under the spotlight. From one side, Azure IoT Edge is based on containerized models. It is lightweight implementation on part of the Docker framework, and you can run any kind of analysis using this Edge platform. Just you have Edge platform as platform component, and you have no need to develop it from the beginning. You have different IoT Edge models. Some models are available from Microsoft. You can have third-party models, and you can create your own models. We have IoT Edge runtime, which is related to main components needed to have proper work of this solution, and you have monitoring of Edge and Edge Cloud interface. It is part of Azure Management Portal, where you can have pretty easy monitoring of your devices, and you can manage it. When we talk about Azure IoT Edge, Azure IoT Edge is a platform for edge computing. It is not only for IoT, but because first this platform stay popular for IoT solutions, it was announced like Azure IoT Edge framework. Main components are three, as I already explained: models, different containerized models, edge runtime, and cloud-based interface, which allows immediately to start to monitor and manage your solutions. When we talk about models, models are, as I mentioned, Docker compatible containers. It is possible to run to build and run this container pretty easy. Containers can be models which are actually containerized applications can be configured to communicate each other. You can develop custom models for any specific purpose additionally to what platform and third-party vendors offer. And you can see the main idea. You have the runtime, you have models. Models communicate via runtime, so you have no need to put effort to implement any logic related to security, related to specific communication in your models. And you have the unified approach how via this edge runtime, these models can communicate with the backend using IoT Hub, and how devices using Azure IoT Edge runtime can work with other devices. It is good to mention that everything is pretty straightforward if you are using Azure IoT Hub. If you have some another specific platform for a cloud gateway, many of advantages related to communication will be lost. So the best option to use Azure IoT Edge is to have IoT Hub as also gateway service. You have no need to think about different details related to specifics for a runtime environment, and you save time and effort for development. This is, of course, the most important. Cloud interface is something which we will discuss later in this presentation. Pretty easy option to start work with Azure IoT Edge. Because this topic is huge, we will have today mostly general explanation and concept. And again, next week, we will go deeper into this concept. So we will have much more specific details on Global Azure Bulgaria related to the same concept. When we talk about Azure IoT Edge, we have one specific component from the platform named IoT Edge Hub. What is exactly IoT Edge Hub? IoT Edge Hub is a component which provides communication with IoT Hub in Azure. And this is something like local proxy where your IoT Hub can um, communicate without need to know much more details with devices with Azure IoT Edge framework. Um, it is possible to have connection and communication using MQTT and MQP. Unfortunately, with HTTP, support is not available, but we have very good options to make almost any flexible setup using these functionalities. Again, later in discussions in this context, I will provide much more details. Azure IoT Edge Hub is not a full version of IoT Hub, and it looks locally. Reduction of bandwidth is significant using this approach, so you have much less data which is transferred between local devices and backend. And when you have Edge Hub, you have two interfaces for local connectivity and for internet connectivity. Again, you can imagine this is something like IoT Hub with limited functionalities running locally, and it is the main component for local IoT gateways. When you deploy Azure IoT Edge, this component, IoT Hub, is one of the first which um, will be needed to run. It is possible to have communication with IoT Hub directly with other components. It is not possible to make all these advantages. When we talk about Azure IoT, you can use, of course, also many other components. I already mentioned about stream analytics, event hubs, storage, NoSQL, multimodal polyglot databases like Cosmos DB, and different types of solutions for analysis like Databricks, SQL database, machine learning models, Power BI, and of course, Azure functions are some of main components if you want to make glue between different um, components which have no direct connection. So, if we talk about architecture in depth, we need to talk a little bit more about how exactly Azure IoT Edge is implemented. And on this level, uh, we have this framework built on top of Mobi, of open source framework that actually is Docker compatible, and it is lightweight framework which includes part of Docker frameworks. Devices can be registered during the initial process, and after that can be managed from the public cloud. It is possible using also device provisioning service to manage edge devices. Edge devices in general are considered like IoT devices capable to run additional services. And you can see this schema. We have this runtime. We have different models. We have two important components here. Um, IoT Edge Hub. We talk about IoT Edge Hub and IoT Edge Agent. IoT Edge Agent is responsible for running and monitoring of different models, and these two components actually are um, separate in the context of a need, because you need always IoT Edge agent. For IoT Edge Hub, you need it when you need communication with the backend. It is possible, as I already mentioned, to do it in a different way, but IoT Edge Hub is the most effective way. When we have communication between edge devices and backend, edge devices usually are um, also in a role of field gateways. I mean, not all edge devices are field gateways, but field gateways usually are also edge devices. Why? Because establishing of connection between devices and backend usually requires some additional computing resources, and that's the reason to need advantages of edge computing. It is possible using edge devices to have translations of protocols. There are different schemas which can be considered on the later stage. When we have communication between models. This communication between models stay via different end points in standardized way using Edge framework, and again, your devices running Edge framework have much simplified concept. Models have no idea about specific security and communication logic. Uh, Agent is probably the most important component, as I mentioned, because you need to have it always, and you need to have this Edge agent configured. Usually we have configuration by default, but some specifics need to be uh, also learned to be possible to have tuning and changes in the later way. Models can be considered as containerized applications. There are also uh, additional advantages using models, because instead to have a very complex logic, if you have different regulations and different specifics for different regions, it is possible just to create models with different configurations and some small changes for different regions regarding to local regulations. And on the architecture point of view, this is often simpler than to have all logic in one universal model for worldwide solution. We need to follow some good practices when we consider IoT Edge. First, we need to know that um, in general, with all benefits, we need to have, of course, consideration of some specifics. We need to mm, imagine that IoT Edge concept in the regarding to Microsoft Azure is something like, for example, deployment of apps for mobile devices with backend services. You have backend logic, you have device where you are installing some specific components, and these components can communicate with backend using unified communication protocol. It is possible in exceptional cases also to have separate endpoints from the devices from where they can actually download, upload data which is with a huge amount, and it is not good to overload the main communication channel via IoT Hub. But from the security perspective and from the point of view of good architecture design, you need always to follow options, if you can, to make connectivity via IoT Hub. I mean connectivity related to uh, specific workloads, not connectivity related to management of devices. Connectivity where we need to manage devices should be always via IoT Hub. Uh, you need to have in IoT Edge solutions on Azure proper strategy. You have edge devices, you can automate device provisioning using device provisioning service, which is tightly related to Azure IoT Hub. You can register devices automatically. You can have model development, deployment, and upgrades automatically. It is possible to create your own models pretty easy. We will have no time for details now, because there is another session after this and we need to finish after a few minutes. But um, you can see next week samples where services like those part of cognitive services can be used also on the edge. You can create proxy models, for example, which communicate with um, edge with backend services. You can also have some custom models which you can deploy on your solutions. For deployment, usually we have uh, pretty easy steps in your cloud management portal. You can just set required settings, and you can register these models. When you deploy machine learning, uh, context is pretty similar, just you need to have, in this case, in advance preparation of your machine learning model, deployment of this model. If you have some updates only in the model, you can do this without changing um, anything on the edge devices, and your model on the edge devices can work with updated version of published machine learning model. About security privacy, we have several contexts. One of the contexts is deployment. Deployment can be manual of or automatic. For devices, if we have manual deployment, it is often for specific cases when you have specific configuration per devices, for small solutions, for proof of concept, but for real world huge solutions, you need to have automated deployment, and usually you just need to have very small differences related to some parameters when you add edge devices to IoT Hub. And registering of devices in device provisioning service is in a similar way. When we have deployment can be on phases and can be also layered. Layered deployment is more optimal regarding to time and consumption of specific logic, but it is more risky when we have phase deployment. You deploy everything for all layers on each phase, and in this case, you guarantee higher predictability because you do everything from the beginning, but you need to deploy more models, more data transfer, more time for deployments. So this is the most important when we have layered property in our solution. It is absolutely um, easy supported from Edge framework. That means some specific properties in your models are only for these models, and you rely on some functionalities of the related models. Rollback is also important. For rollback specifics. Usually we have need to follow the specific sequence. To summarize, we need to have checklist, device configuration, deployment, container management, networking, and solution management like main parts which you need to check when you have deployment. Now, because we have limited time, I will just have short demonstration regarding to what we can consider in our IoT solutions when we have edge devices. When you have IoT Hub, your edge devices are separate group of devices. For IoT Hub, you can see here you have devices from one side, and you have IoT Edge. You can have edge devices registered as IoT edge devices in this section, and when you choose specific device, you are able to see models which are deployed, and you are able from one side to manage your models. It is possible to make some changes. It is possible, if you have some changes, actually these models will be updated automatically in configuration. You have environment variables where you have connections, when you have some other parameters if it is needed, and you see that there are desired values and reported values. It is concept pretty well known from digital twins. For models, you have model identity twin. That means you have two configurations for models in the same way, like for IoT devices registered in IoT Hub. You have desired configuration with desired models, and reported configuration with reported models. And you can check from the cloud interface at any moment what is the state of your device configuration. It is possible also to create additional devices in a pretty similar way, automatically or manually. For already registered devices, it is possible using scripting, using a management portal, or using specific applications and SDK to make changes also regarding to models. You can, for example, manage existing models. Using set models, it is possible to create also a new model. So you can add a new model and to create it in this interface. All these details we will discuss next week with a very specific practical session. So stay tuned, and hope to see you again next week with more deeper practical sessions about um, Edge, IoT, and AI analytics. Thanks one more time, and enjoy the conference.